I'll just do Control Z. So we come here, and this is the example I showed. So initially they're equal. We run the program, run in terminal. They are equal. Let's force this condition to be false. So we change this one to 4. Run in terminal. And now no statement displays because they are not equal, right? So meaning this was false, so then it just skips to the next statement, which is return 0. Afterward, our program exits. Okay, so most of the time when we're coding, we want to use functions, right? So in this case, we go to if, well, actually we go to Explorer, and let's go to if.h. And let's say function prototype is even that accepts an int and returns a bool. So it returns a bool. It's is even integer num. Okay, so that's the header. And then we go to the CPP, include if.h, copy the function prototype, open close curly brace, and then here we can determine if a number is even by creating a Boolean expression. So we can say if number mod 0, right? So when we do this, meaning like is the result mod 2, right? If the result of dividing a number by 2 equals 0 true, then it's even. If it's false, then it's not. Okay, so that's what we're saying here. And then we say return the result. Or if we want to save lines, then we simply say return num mod 2 equals 0. And now we can go and write our test case. I mean, very simple function, but we can write the test case to test, make sure that we set up the code correctly. So we go to classwork, assign 3, decision test. Loops shouldn't be there. So if.h, so now we have access to the isEven function. We create a test case. Even function, and we create one assertion. Actually, we'll create 2 assertions, right? Since this is so we say if is even, and we send in the number 2, then the result should be yes, it's even. And then we can create another assertion. And then we can pass the number 3, and then we know that that one is not even, so then the result should be false. And then we can execute our test case, and this test case should pass, right? So we come to CMake, we go find our test case, classwork test 03, right click, and then run in terminal. And it's executing. It's still building or linking now, so. So again, notice here now we have 2 assertions, right? Because now we know that if we test, oh, what did I mess up here? Oh yeah, I went to classwork. Why did I do that? I went to the wrong one. I went to classwork test. So let me cheat here, and let me put loops back here. Yeah, so I went to the wrong test case. Examples test. Who was that? that said something right now? Sorry. Thank you. Okay, thank you. Yes. So yeah, I was in the wrong one. So include if.h, and then I copy the code here, and now I can execute it. So run in terminal. Yeah, so the configuration for CMake was telling me like, yeah, I don't know what you're talking about. Even though I included if.h, the CMake configuration for classwork test has nothing, or doesn't know about if existing. So then it's just kind of like, I don't know what you're trying to do. Okay, linking. I used to have a slower computer, and this one's faster, but it still compiles slow. Okay, so the test case passed. So then by now you know that we can do up arrow, as long as we're here, space dashes, enter, and we can see that our function is working as expected. If we send in 2 as a function parameter argument, it returns true, and if we send 3, then it returns false. And we simply used an Boolean expression here. Okay, that's all we did. So now let's create another function. We go to, and then we'll use them both at the same time. We'll use them in main. Okay, but let's create both functions first. Say write function prototype for function named overtime that accepts a double and returns a bool overtime and double, assuming hours, and copy, and we go to if.cpp. If.h is included already. We can come here, open close parentheses, and then we can assume, for example, that there's no overtime, right? That way we don't have to use an if else, we just use an if. And then we can return the result, but before we return the result, we can say if hours greater than 40, then the result is true, meaning yes, there is overtime. So when we structure the code like this, then we don't need an if else, right? We're just assuming that there's no overtime, and then we check this Boolean expression, and if it's true, then we change the result to true, and that's what we return here. Okay. And with this one, we can also create a test case, and we can create 3 assertions. So we can create one for less than 40, and one equal when the number is 40, and then one when the number is greater than 40. So we have 3 assertions in one test case. And we come back here, and we can create our test case, test overtime, and we create the assertion, and we say overtime with 30 hours, and that should be false, right? No overtime. Oops. And then we can say 40, and that should also be false. And then finally we can say like 42. Now that is overtime, so this one should be true. So now notice how we are creating more assertions to test the different cases that we can encounter for this case, right, overtime. So we can right click on the test case, and we can run in terminal. Okay, still building. Okay, so 6 assertions passed. Up arrow space dash s enter. So now we can see that if we pass 30 as an argument, then that's no overtime. 40, that's no overtime, but if it's over than 40, then yes, there's overtime. So that's how we can derive or determine how many assertions to create per function, right? It all depends on the function. Here, in the is even, I mean, there's only 2 options. Like it's either odd or not. So then that's where we can use 2 or 3. And here, there's really 2 options, but we want to test 40 to make sure that we set up our Boolean expression correctly. We did, right? Because we had greater than 40, but we should never trust ourselves. So that's why we went ahead and said, well, let's test 40 also to make sure that that's not going to pay overtime. Questions? Here? No, I mean, again, my purpose here is to show how to use just the if statement, not the if else, just the if statement, right? So, I mean, there's a lot of, there's different ways you can set this up, yeah. Any other questions? Okay, so let's use this in main. So we come back here to Explorer, and we come to main here, and create a bool variable named even. Okay, even. Create an int variable named value. Okay. Prompt user for a keyboard, for a number from the keyboard. So meaning, first let's tell him what we want. Enter a number, so that the user knows what we want, right? So cout, enter a number. Now we want to capture input, and we say save the value that the user gave us into the value variable. Okay, so after this statement, then we can use this value. So we're saying call this even function. Okay. Okay, so even, this even variable right here. And again, there's different ways to do that. I like to create a local variable because usually we want to do something with the result. Is even value. And here we're not going to use if else, right? All we're going to do is we're going to say if even. So this is equivalent to saying if even equals to true, right? So if we just say if even, then this guy is going to be either true or false. So then it's qualifies as a Boolean expression. So then we'll say character output value is even. For now, we're not going to worry about if it's not even, okay? Because we're not talked about the if else statement. So if it's not even, then it's not going to display anything in this case. Questions here? Okay, no question. So we can execute this program, and now we come back here, right click, run in terminal. Enter a number, 50, so value is even. Should be able to hit up arrow and run the program from the command line. Enter 51, and nothing's displayed. So nothing's displayed because, well, I mean, I'm only displaying something if the number's even, okay, in this case. And this is a simple program. What is the other function we used? overtime, so we can daisy chain them, right? So then we'll say we can reuse the value variable again. So then here we can say, okay, so enter a number. Let me make sure that I have a new line character there. And then I can say, well, I simply want to display whatever result the function overtime returns. Okay, so it's either going to display what? What do y'all think this is going to display? Only two options. When statement 30, go ahead. Yeah. True. Yeah. Or a number 1 or a number 0, right? So, yeah. So let's go ahead and execute it. Run in terminal. 50, we say 40. And then we say here 41. Right, so notice it displays a 1 because, well, 41 is overtime. If we would have put any other number that's less than 40 or equal to 40, then it would have displayed a 0. So even though we see them as true or false, the compiler stores them as ones or zeros in memory. Okay, so any questions on this workflow? How we started in the header, wrote code in the CPP, tested on the test case, and then finally used the program here in main. Mm-hmm. Yeah. In this case, I mean, I could have created another value variable, but since, and it's mainly a program for demo purposes, and we can reuse the variable, right? We can do that, like you can, and that's very common to reuse a variable. Right here, we don't need it anymore, right? Once we send in the value of value into isEven, then notice here I don't use value again. So then I'm like, okay, I can use value again over here. It's just storing a number. So then I'm like, okay, let me use value again, and then I can use it again as a function parameter argument. Oh, okay, but that was the case, then it becomes a different number here when we capture input again from the keyboard. Okay, yeah, sorry about that. Yeah. Any other questions? Okay, so that was if, and now we move to if else, and the if else syntax is like this. So the basic syntax is if some Boolean expression open close curly brace, and then else, and then open close curly brace. Oh wow, yeah, that's what it is. Notice there's no Boolean expression on the else. Okay, so in this case we're just saying if this piece right here is true, execute this portion and then jump to the next statement over here, whatever statement would be here. If this is false, then do the else piece, and then execute the code that will be here. Questions on this one? Okay, so we go to the Explorer and we go to the if-else piece, go to the header, and let me see here. Okay, so returns a string. So it returns a string. We need to configure that special data type string. So we say include string, and then we can say start a string, right? Because it returns a string. Get generation accepts an int. Okay, so int, and then we'll say, I guess, year here. This is going to be an if else if. So how should we do this? Well, maybe I should just show an example here in main first, right? Using if else. So I'll do it here at the top, very basic example, right? So we'll say using x and y again. So we'll go back to that simple example I created initially. So if x double equal sign to compare equals y, then cout they are equal, else cout not equal. A semicolon. I don't want to execute this piece right now, so I'll just cut it for right now. And then I can go to CMake, and I can execute this program, run in terminal. So they are equal, okay? And then if I make them not equal by changing this to a 4, I execute the program again. And then it displays not equal, right? So that's what happened to my semicolon. I didn't notice that. And now we can, so any questions here on how to use the if else? You left a semicolon in the string of your out. Oh yeah, thanks Nick. Yeah, I was wondering what happened to my, I was like, I thought I typed a semicolon. Okay, so now let me go back here, and we can modify our code here, and we can say else cout value is odd \n, and we can also, well, we won't execute this code, right? Unnecessary. So we'll execute this code, right? So now we'll be able to see the output value is even or value is odd, depending on what number we capture from the keyboard. So I come here, run in terminal, and I'll use the number 3, so value is odd. And if I execute it again and I say 4, then value is even. And that's how we use the if statement. Let me make sure that I put this code there. And that's what I'll check into my repository. So it shows you if else, and then in the function it shows you how to use the if statement. And I'll check that code into my repository. Any questions? When do you use a negative number? Let me run it. Oh, okay. See what you're saying. So let me see. -4, enter, -2, enter. Okay, so that was for overtime. So yeah, so it'll still work because the integer data type supports both numbers on the left side of the 0 and on the right side, right? So okay, so yeah. Okay, so we had this piece, get generation, and this one's going to use the if-else-if syntax, right? So if-else-if. So this one is if, I'll just put BE for Boolean expression, okay? Because I want to retype all that. And then else if, now it does require a Boolean expression, open close curly brace, and then we can say else, open close curly brace. So just remember, like if you use else, then no Boolean expression. If you use if and else if, then a Boolean expression is required. And we are going to use this structure to create that get generation example. So we come here and copy. We go to if-else.cpp, include if-else.h, copy the function prototype, open close curly brace, and there's several ways, or two ways that we can write the code here. We can create a string variable here, and then meaning we can say string generation, and then we return that, and then we start creating the conditionals, right? So we can say if year greater than 1995, and, right, the double ampersand, and you have to make sure that you use year here again, okay? You just can't say and like less than 2015. You can't do that because it doesn't work like that. You have to make sure that you put the year here also, okay? So please don't forget that. That's a very common mistake that students make. So now once we do that, then we can say generation equals what? And then we say centennial, okay, centennial. And then it returns generation. Another way that we can handle this is we don't have to return, create a local variable here, a string. We can simply say return centennial, right? So either way works, but since we started with this, and that's what we'll stick to. So we declare, assign, return. And when you're writing code that has function code that has several branches, then it's a good idea to be writing your test case as you write your code. Why? Because we want to catch the error right now. We don't want to catch it later. So we can come to decisions test here. Not it. Let me see here. 0 2 modules test. This one, right? No, 3. This one. So we come here and we can create our test case. Test get generations function. And we have one assertion. Require. Get generation doesn't exist. So we need to come up here and we have to include if else.h. Okay, so include if else.h. So now we can use get generation. Get generation's available for us, and we enter some year like 2000, and we know that that should return centennial. In this case, since it's a string, the case has to match. So if we spell and the spelling, right? So this one's not going to pass right there. And the spelling has to match. Otherwise, our test case will fail. So let me see, centennial. Okay, so we can execute this test case to test that branch. We come here, right click, run in terminal, and it's building. Here, so here, yeah, 2000 right here. So it accepts a parameter. Yeah, that happens to me too. Sometimes I get confused. It still happens to me. Like I'm even at work, like I'm helping a developer, and then it's like something so trivial, and it's kind of like, you know, we just lost 2 hours here. Okay, so space -s enter. So notice that it's correct. So then we can create another assertion and put like the year 1600. And what did it return? It's invalid year. Okay, we've not coded that yet, but we'll say invalid year, and we purposely run it to show you that it's going to fail. And it's still building. And building. Okay, so notice that it failed, and it's nice enough to show us right away. Like, you're saying that it should be invalid year, but I didn't return anything. It didn't return anything because we're not coding for that. If we would have set the, go ahead. Usually the recommended, yeah, I understand. Usually the recommended way is to test as you're coding. So we coded this, and I mean, I purposely did this just to show you that, well, it's going to fail, right? But we can fix that right away. We can say else generation equals invalid year. And now if we run the test case, then now it's going to pass. So we come here, right click, run in terminal. Yes, it's called test-driven development. So we want the test cases to help us write the code, and in doing that, like, it's making sure that our code quality is always as high as we can get it, right? So notice now we're passing, so meaning we're good. We can verify that by doing up arrow space -s, and now notice now that this else fixed our test case. So we can continue. So what I'll do here is we'll say if else, we need a condition, So we say year greater than 1976 and a year less than 1996, open close curly brace. Yeah, sorry about that. Else if, and then we can say generation, and that's what, a millennial? What? A millennial, right? Millennial. And we can come back to our test case and then create an assertion for that, right? So millennial. And I know that this is kind of like really like that's a waste of time, but that's how they recommend coding, because you capture the errors right now. I mean, this function is easy, right? We're just using if-else statements. But if a function has complicated logic, then we want to catch the test, the error as soon as it happens, right? So this will be like, what, 1980? Right. And that's the whole purpose. Yeah. Yeah. I think because in the summer, like I did have to, I mean, I did go faster because I wanted to cover as much as I could, you know, so students could be ready for programming 3. Yeah. Okay, so no, don't say that. We're going a lot slower. Yes. Yeah, it does. Let me find it. Yeah, so here it's saying that in module 3 at line 26, so this is module 3 test CPP here, line 26, which before was invalid year, right? It was this one. It's saying this assertion failed. Like there's something wrong. So then you can go and, okay, I'm passing 1600 to my function. You can come into your function and then you can 95, 76, and say we didn't have this piece, and then you could be like, oh, I don't have any code that handles numbers less than 1925, right? So then my code's going to fail. But now we capture that with the else, right? So it tries to help you as much as possible to tell you where the error occurred or where it failed, and then it's up to you to go into the function and fix the code, which is what we want. We want it to kind of pinpoint to us where our code's failing, so that we don't have to read every single line of code. So then that's the whole purpose, yeah. Like we want to be confident that our code works. And it's like I say, right now, you just want it to work for main. But if you're working with Python, Java, C# in a programming shop, before you merge your code, the senior developer is going to want it to work. And he's not going to take your word for it. He's going to want to see test cases. So before you can merge, even if you tell them, well, yeah, the test case is passed, they're like, okay, let me see. So then you have to show them by running the test suite, and then once the test case is passed, then they sit down with you and they start asking you questions. Well, why did you do this? Why did you do that? Maybe you should have done this, right? So, and it's all like to make you a better programmer and to produce a good product. So that's the whole purpose behind test cases. Okay, so did we run this or no? I don't remember. Let's run it. And then after this one, then we'll just hurry up and finish all the conditions, okay? Because we won't be able to finish it. But I wanted to show this step And this is a step I recommend you all follow when I give you functions that are more than one line of code that you know can produce different results, because you'll finish faster. It's kind of like, really, I'm writing more code, but believe me, writing test cases to test your code, you'll finish faster because you'll know right away where your errors are occurring. Yeah, so linking. Yeah, where I work, there's like some old school programmers that didn't like when I was asking them to write test cases, because, so millennial past, because, I'm a good programmer. I've been programming for 40 years and my code works, but I mean, why not use tools just to show that, yeah, your code works, right? And you produce better programs. And then it's like I was saying at the beginning, you're not fixing bugs all the time. You're adding new features because your code's tested. Okay, so notice here it passed. So what I'll do now is I'll just come here and we'll try to finish fast. Generation X. Okay, so let me do this. So year is 19, so greater than 1964, less than 1977, and this should be generation X, and make sure I put a double quote there, and then come here, and now we have the next one, which is baby boomer, greater than 1945, so greater than 1945 and less than 1965, and this would be baby boomer, and we have to spell it the same, so that's a lowercase b, so I have to remember that for my test case. So. Yeah, I mean, you can do that too. I mean, as a matter of fact, the recommended way is like write the test cases before you write the code. And for some especially like programmers that have been used to coding, what they call like cowboy coding, they don't like that. But yeah, so that's test-driven development. So we have here 1924. 1946. Also, my mom's a baby boomer. And this one's the silent generation. Yeah, I think I got him right. Okay, so I have all the cases, so then I can come here and then I can start. So this one would be 1970 maybe, and that would be generation X. And then this one would be 1950 baby boomer. And I said lowercase b, and then finally the silent generation. Who comes up with these names, right? So silent generation, 1930. And then we'll do one more. We'll do like the year 2025 or something. Those were dark times. 2020 is up there, right? So let me see here. So run. Yes. Just like we did for these cases, but I'm running out of time, right? So just like this one. Yeah. Yeah. But you're right. We want to touch the edge cases. Yes, we should be doing 3. Yes. I think this is the last. Oh, let me see. 648. Can we do the main? What's in main? Just to complete this example while those test cases run. So let me see here. Yeah, so this one we simply say int year cout. I can just use cout because I've configured it, right? So cout, enter a year, and then I can say cout generation is if else is included up here, so then I can simply say get generation and pass the year, and then I'll display the result. And let's see, make sure that the test cases pass, right? So all the test cases pass, but Justin is correct. Like we should be testing edge cases, meaning the beginning and the end and somewhere in the middle. But I didn't have time to do that. So here, I didn't ask the user for a number, so we have to write, so cin, a value from the keyboard, save it to the year variable. In the next statement, the value that I stored in year, I want to pass it to the getGeneration function and display the result. And once I do that, I can come back here and run the program, which is if else, right click. So by the time I get here, like Grecia, I think Grecia was saying, like I should be confident that my program's going to run, right? So, and it's going to run correctly. So enter year 2000, right? So generation is centennial. There's no loop, but I mean, when we get into loops, then we can write programs that never end until the user opts out. So at 6:50, so it's the end of the lecture. Let me stop here.